Dear friends, today I am going to discuss with you a problem of mutual induction. I am having a loop in which there is a battery, some current is flowing. Let I call this current I1 and it is in a space. So coordinate system for space, I consider a small length element dl1. Current element is I1 dl1 and it is a vector quantity. Now then I am having another loop, arbitrary in shape and size. Let this loop is C2 and I consider a very small area. Because this is C2, I call this area ds2. Now from current element, this is a position vector r vector. Now according to Bauer-Source law, what is the magnetic field at here? Okay, magnetic field at here it is B vector, constant, current element cross r vector upon r cube. This is the magnetic field at here. Now what is the flux at the same position with area, this area ds2. This is a very small area, this area. So flux is, you know very well what is flux. And let I consider the field at here not because of one element. I consider field at here because of the total loop. So I integrate this expression, okay, and for the whole loop C1. Now the whole loop, what is the flux at here? That flux is phi 2. Phi 2 is B2 dot ds2. Substituting the value of not B2, B only. B means field of this loop at here, B dot ds2. So phi 2 becomes, phi 2 means flux at here. It becomes, substituting B, so mu naught over 4 pi and then C1 I dl1 vector cross r vector upon r cube. Then we are having a dot and then ds2 vector. ds2 vector. Now there is a result of del vector with 1 upon r. The result is minus r vector upon r cube. If you don't know this result, then please write me in the description box. Then I explain to you. Okay. Now instead of writing here, this r and r cube, r vector upon r cube, I write it here minus del vector 1 upon r And again using A vector cross B vector, this identity, minus B vector cross A vector. So it will be minus sign here, but using this identity, I can write this expression phi 2 is equals to mu naught over 4 pi C1. Now here it is I dl1, but I am writing this first to absorb this negative sign, because then negative and negative becomes plus. So I write first this, then after that I'll write, because A cross B is minus B cross A. So it is del vector 1 upon R, then what? Then cross second vector, right? Then dot ds2. Okay. Now there is a result that will use del vector cross phi into A vector. This result is phi del cross A plus del vector phi cross A vector. Now here I'll assume phi, which is a scalar, that 1 upon R, and A, what is A for my case? A is I into dl1 vector. So applying the result, so del cross 1 upon R I dl1 vector is equals to, now phi means, what is phi? 1 upon R del vector cross A I dl1 vector plus del vector phi mean 1 upon R cross A vector I dl1 vector. Now the del cross I dl1, this is 0. What is the reason of like this is why it is 0? Because this is I dl1, and del mean the variation of the space with respect to the second coil. With respect to the second coil, there is no variation, there is no change in I1 dl1. Okay, the variation of the space with respect to C2, there is no change of I1 dl1. So that's why it is 0. It is 0, then what it becomes? So we are having this vector, and this vector the same which is at here. So instead of writing this, this, I can replace it with this. Okay, so that means phi 2 becomes mu naught upon 4 pi, then C1 C1, then instead of writing this, I am writing del vector cross I dl1 upon R into ds2. Actually, this is a small flux which is linked here, very small flux. I am interested, what is the flux? What is the flux which is linked with the whole surface? Okay, whole surface. Then for whole surface, means this is a small flux. It is actually d phi 2. So the total flux means phi 2, and then I have to integrate this expression for the whole surface S2. Okay. Now this becomes the total flux phi 2. Now I am going to use the Stokes theorem, where the surface integral can be replaced by the line integral. But because this is ds2, second surface, so total phi 2 becomes mu naught upon 4 pi. This was the already line integral for IDL1, but for I am going to replace ds2, this surface, with the line integral of the second loop. Okay, then I am having here, I am not having now del operator, only use Stokes theorem. I dl1 vector dot dl2 vector, okay, upon R. This is phi 2. Now you know what is a mutual induction. Mutual induction is like I am having a coil, and if some current is passed through it, then this current will behave like a magnet. When it behaves like a magnet, having the magnetic flux, okay, having the magnetic flux, because the battery current is flowing. When current flows through a coil, it behaves like a magnet. If it is a magnet, having magnetic field. If it is a magnetic field, there is a magnetic flux. Now I am having a second coil, which is just placed nearby, and galvanometer is attached. You know, the flux of this coil will be linked with it. The flux linked with this coil will be phi 2, and this flux linked will be proportional to how much current I1 is flowing. If the less current is flowing, the flux linked with this coil will be less. Phi 2 proportional to I1. Okay, and then phi 2 is replaced, proportional sign is replaced by M21 and I1. So M21 is the mutual induction of the second coil with respect to first coil. Current was in the first. Now in our case, current was here, it was I1 in the first, and I have calculated flux which is linked with the second coil. So here in our expression, this is actually I1. So current in the first loop. Okay. Now comparing this expression with this 5 to 5 to I1 mean mutual induction M21 will be mu 2 upon 4 pi C1 C2 then dl1 dot dl2 upon R. This is M21. Mutual induction of the second coil with respect to 1. Now, if our case is like battery is attached in this coil and you are calculating what is flux here and you calculate then M12, what is how this coil is linked with this. Before I calculated how this was linked with it. Now I am calculating how this coil is linked with this. Okay, because the current is in this, how it is coupled with it. M12. So similarly, if you calculate M12, in the same way, the results comes out mu naught over 4 pi C2 first, then C1 dl2 dot dl1 upon R. I think because A vector dot B vector is B vector dot A vector, that means there is no difference between the two. So that is M12 equals to M21. This is very, very important result, and this result is called reciprocity theorem. Okay, so if in the exam they ask you explain the reciprocity theorem and give its proof, so this was the derivation. M21 equals to M12. I think it is clear. If not, then don't hesitate. Write me in the description box. Okay? Thank you.